Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by Linode, our cloud server of choice. It is so easy to get started with Linode. Servers start at just $5 a month. We host changelog on Linode cloud servers and we love it. We get great 24/7 support, Zeus-like powers with native SSDs, a super fast 40 gigabit per second network, and incredibly fast CPUs for processing. And we trust Linode because they keep it fast, they keep it simple. Check them out at linode.com/changelog.
Let's do it. It's go time.
Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Go for Slack. Follow us on Twitter. We're at Go Time FM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello, Go Time listeners, and welcome to the first episode of 2020. My name is Johnny Borsico, and I'm joined by an exquisite panel today. Joining me are Matt Ryer, Carmen Endo, Yana Dogan, and our special guest, Kelsey Hightower. Hello, Kelsey, and welcome to Go Time.
Oh, awesome to be here.
Good stuff. So it's 2020. And I don't know about y'all, but usually after the holidays, I have this sort of haze. I'm just trying to come out of the little bit of time off and trying to figure out how to compute again. I'm not sure if anybody sort of experiences that. Matt, I'm sure you do, because you're always like that, right? No?
Yeah. Basically, yeah. That's how it is for me. But no, it is hard, I think, sometimes to take a break. But if you can do it, it is worth it. And then, when you get back, you sort of, I really miss it, so I'm really keen to get going again once we start. So I've had a good week so far, actually.
So a new decade is like a time for reflection, and I was able to reflect back. And I noticed that in 2020, the most CPU-intensive application is my web browser. And I never thought that's where we would end up in 2020.
Yeah. They didn't predict that on Back to the Future, did they?
No, tabs, Chrome tabs.
We can't invent flying cars because we're too busy trying to optimize our browsers.
We're too busy on Twitter. Yeah.
Yana, welcome back to the show. You've been gone for a little while.
Yeah, I took a couple of weeks of breaks, I think, here and there. I'm still trying to come back. Last day was my first day at the office. And, I was questioning everything. Hey, am I really qualified to do this job?
The important question, though, is, does your badge still work? you come back from holidays and you have trouble badging in. That's a sign.
It's you get that little heart, your heart skips a beat. Yes. Crap, what happened?
Gosh.
Yeah.
Yeah.
I've had that. I was using my bank card. I thought I'd been fired. Couldn't get in.
I'm trying to work from home, to be honest. I have this suspicion that I can get, fired anytime. I'm just, working from home. It's better not knowing.
Just be home anyway. Be like, whatever.
Any day could be your last. That's rough. Carmen, how are you?
I'm well. I need a vacation from my vacation, I think, but it was nice to get time off.
That's good. Like Kelsey says, it's time for reflection, and I think we should do a little bit of that for 2019. It's been a big year for cloud, I think, and I don't think there's anybody here more qualified than Kelsey to talk about sort of the impact that really things like Kubernetes and things coming out of AWS and all the other cloud providers, the things that they're doing, and it seems like they're pushing the boundary in terms of what makes folks productive, right? So operators are impacted, developers are impacted. And when I try to wrap my head around everything going on in the industry right now, it's kind of hard to see sort of, I'm seeing blurred lines. And maybe, Kelsey, this is something we can start with. I've been an operator and a developer, so I kind of get a sense of on both sides of sort of what lens to look things that I'm with, but if you're a traditional operator, like what does technologies like Kubernetes, for example, how are they changing life for you? And on the other side too, as a developer, like what should you care about? Like where's the line here? Or is there even a line?
Yeah, so the good news is I think 2020, the hype is now just dying off. This is good. We're finally getting to the point where most of the new projects are just remixes of the existing ones. Communities are merging. We saw this kind of with the open census, open tracing communities to open telemetry. So now that we've did a lot of experimentation, I would probably say the last 4 years have been just trying ideas from infrastructure all the way to developer tooling. And now what we're starting to see is that the buzz is kind of dying down to now people are more focused on production. And I think one good indicator is probably we can't extrapolate big, but when Docker canceled their conference coming up in 2020, right? I remember 2.5 years ago, if you were at DockerCon, it felt like that thing was never going to stop growing. It was like at 5,000 or 6,000 people, and there was just no end in sight. And then now they're moving to a virtual conference, and there's probably all kind of reasons for it, but my guess is the attendance probably started to drop or shift to other events. But that's a good signal to me to indicate that now we're in this other phase. We have all of these tools. Let's just put them to use. So now we're getting to that part where I think I like is when infrastructure gets boring, something else will become exciting above it. But right now we're starting to be in that phase. So I think if you're a practitioner looking at all of these things, you've made it. We're on the other side of the hype curve now. You can stand back and just start to really listen to what people were doing in production. And you're going to probably see a lot of good examples in the wild of what people actually are using versus what's being said out loud or inside of that hype cloud that we just came out of.
Mm-hmm. So are we still at the stage then where things like Kubernetes we're still trying to figure out how we should use them, what we should use them for? Obviously, you can approach this from different angles. If you're trying to build a platform for folks to use, or if you're trying to run your own data center for your own business purposes, like I think there's still some confusion around like who should really be sort of adopting and using Kubernetes and for what? Are we still in that phase where there's some confusion around its use cases?
Some people are, but luckily for me, I was there from the very beginning, and now I'm stepping back and reflecting, right? If I reflect back, Kubernetes is about the how. Everything underneath is still the same. The kernel is still there. The virtual machines are still there. What we did was change the how. So before Kubernetes, Puppet, Chef, or Ansible was your tool of choice to do some of the same things with multiple machines. Kubernetes changes the how. Some people call it abstractions. We introduced things like pods. We leverage some distributed system principles around service discovery. But all of that is just the how. How do you find your applications? How do you configure them into the load balancer? Now, the interesting thing here is, as part of that journey, we decided to take the Linux machine and treat it like the hypervisor. So we moved networking, security, all of these things that you typically got from a cloud provider like IaaS, or if you're on VMware on-prem, VMware already had these things to integrate your machine to the rest of the environment. We had to go rebuild all of that in the Kubernetes world, and we got pretty far. We did a decent job with networking. It's still confusing for a lot of people to be managing bridges on Linux machines instead of having the underlying networking fabric. And then we also did another thing is we took the application packages, container images, and we decided to just let them run side by side on the kernel. And we spent the last 3 or 4 years trying to securely do that. And that's a very hard problem because the Linux kernel isn't designed to give you that kind of security for untrusted workloads. And now we're coming back full circle, where now we're going to take those container images, some of the things we got from the Kubernetes world, aka a pod, one or more containers, their volumes and their dependencies, and we're going to put them on micro VMs. Mm-hmm. So we just went 5 years to come back full circle. We made the VM smaller, but we're keeping the API from Kubernetes, we're keeping the container image, and now we're back to much better virtualization, almost the original purpose of cloud.
Interesting.
Does this mean that like individual nodes at some point end up being a virtual machine? We are trying to have like, multi-tenancy. Do you see that like Kubernetes API is just like replacing all, and, each pod is probably like end up being a virtual machine in the end?
I can almost guarantee right? Like guarantees are bad because people will come back and listen like, dude, you were so wrong. you were overly confident. I am overly confident that we will go back into a world where there will be one pod per VM. But the thing we call a virtual machine is dramatically changing. I think Amazon hinted to this with things like Firecracker, right? We saw Firecracker come out, and for those that know their history, Firecracker comes from the Chrome team, where they decided that they wanted to isolate things at this level. And when you can isolate things at this level, almost using some of the machine level isolation, then you can actually isolate a web browser tab. Amazon is isolating serverless workloads. Now you're in a really interesting spot because guess what? One thing we already have. Every cloud provider has a really nice hypervisor layer that most people don't see. We already have things like VPCs, Direct Connect. So imagine saying, let's strip the kernel down by, let's say, 80%. Strip down the virtual machine, no floppy disks, no things we don't need, and then just pack the container or the pod in there. So that means you could be using the Kubernetes API, but all you're really doing is launching these lightweight virtual machines connecting to the existing stuff. And now we can take the 8 years of advancement in the cloud or VMware on-prem and pair it with all the beautiful things we like about Kubernetes.
One of the things I've heard you speak about a number of occasions is getting to the point where the things that we're sort of moving around as the folks who look after the infrastructure is really data, right? So it's almost like, I think the terminology used is infrastructure as data. Like, can you talk a little bit more about that? Like, what exactly does that mean to me if I'm moving around YAML files today to try and set up, clusters and manage infrastructure? What does that mean to me?
It's funny. People complain about YAML. Like, oh my God, YAML's so terrible. And you have to step back for a second. So I'm going to just kind of talk through my journey of this to get to where I get to the concept of infrastructure as data. If you have 5 Linux machines, the first thing you're going to try to do is write some bash scripts, right? You're going to write some bash scripts, some for loops. You're going to SSH things around. And if you've ever seen people write bash scripts over time, you go into their home directory. You see files like do this stuff 01, do this stuff 002, but don't use it anymore because you should be using the other script. So you have no version controls, you have no semantics, no abstraction. You're just writing bash scripts. Fast forward to configuration management, right? We get things like CF Engine, big shout out to Promise Theory. And then we get Puppet, Chef, and Ansible. And then they formalize. It's almost like the Ruby on Rails for shell scripting. So now we have this configuration management error, and we all start to say infrastructure as code. Problem is, now you have to test it. People can write any code they want. It's unbounded context. And it's the same problems we have with software. How do you secure it? You're going to have bugs, right? It's just all over the place. But it is a better place to be than we were before. Now let's get to infrastructure as configuration. Now where we're moving is all of the abstractions into the runtime. So the how. How do you create a load balancer? What goes in the load balancer and how you remove it? That implementation detail, we're going to have a lot of discipline, and we're going to move it into these controllers. So if we're talking about Kubernetes, these are going to be the controllers. If you've been in cloud, you've already done this, right? We always have control planes that do the heavy lifting. Same is true for networking. We expose ports and protocols, not the control plane. So configuration as data, we get to something very similar. Now what you say is, I want a load balancer in this region pointed to those services. No for loops, no if statements, no programming language concepts. So all you have is a data model. And that data model represents everything that the state machine on the other side can do. Why is this more powerful? Well, when you're working with data, then you can manipulate the data much easier than you can manipulate code, right? We've seen this before, right? Like in the Go world, there's like 10,000 Hacker News posts. Oh, the same thing, but written in Go. I prefer Go as my favorite language. So every time we do things in a language specific way, we end up having to rewrite the thing to be compatible with those libraries and so forth. But when you move to infrastructure as data, we can have these high-level APIs. You can write them in JSON. You can write them in YAML. Or if you're enterprise, you can go XML if that's your thing. Oof. But either way, every tool that comes out from here going forward can translate all the data that your infrastructure is described in to do something else. That's extremely powerful. And I don't think people have really comprehended what this means going forward.
It reminds me of actually like JavaScript frameworks and things. A lot of those are, you essentially have data and they're applied against a template. And then you just focus on changing that data and mutating the data in different ways. And that's what they mean by reactive. Then the experience reacts. And when you actually work like that, it is sometimes really quite surprising what it does automatically. And, if I think about that as an idea applied to infrastructure, it really does, from my point of view as a user of this, that is massive. It is kind of a very different way of thinking about it. And yeah, so I wonder, in the design then, through the life of Kubernetes, because, building abstractions is hard, were there any abstractions that didn't fit or things that didn't quite work that had to evolve differently? Or because of the nature of it, were you able to kind of get a good design from the very beginning?
This is where I learned the most as a developer from working in the Kubernetes community. So big shout out to Brendan Burns, Joe Beta, and people like Brian Grant that were a little bit more behind the scenes. The work that they put into the API design, also someone named Clayton Coleman from Red Hat, they spent so much time on the API design. So when you open up a Kubernetes configuration, you see, hey, API version, and then the API group. And there was maybe about halfway into the lifetime of Kubernetes, we decided there should be a thing called core. What's required to run a container? So you need things like the scheduler, you need things like what is the definition of the thing you want to run, the pod, and you need something like a replication controller. These things kind of represent core, including things like services and so forth. With those core primitives, you can build everything else. Red Hat came along and said, you know what, we can't just give customers raw Kubernetes. And they have this concept of OpenShift, right? It's like a PaaS in a box, very similar to things like Cloud Foundry. And they started adding things like deployments and namespaces. So those two things come from Red Hat. The problem, though, is they're very opinionated things, like a deployment that does rolling updates a certain way. What if you want to do something like a blue-green deployment or a canary rollout? Deployment object is very opinionated in how it rolls things out. So we decided to say, hey, let's slow down for a moment. We can't bring all of OpenShift into Kubernetes. We should probably leave those things on the outside. And I think Brendan Burns came up with this idea of the custom resource definition. This idea that you could just give us your schema, we would generate the REST API for you, so all the tooling will work, kubectl will work, and then you can actually implement your own control loops that would then watch for this data to show up in the system, and then you could build your own platform. So in wrapping, the thing to take away here is that the first system we built on Kubernetes was a thing to manage containers and services. And then people went on to build things like Kubeflow for machine learning and Istio for networking and service mesh, all on the same principles. Control loops do the implementation. Your data model represents what that control loop can do.
Kelsey, are there cloud problems that you can't solve with the CRD approach that you were trying to work around?
This is a really good question because I go to all these companies and they're just making CRDs for everything. Like there are CRDs to take a shower. I'm like, dude, no, you just literally go take a shower. You don't need to do kubectl apply. Take a shower. Like, come on, we're going a little bit too far. So I think what people have to understand is that there are things that really work well in a declarative model. And there are things that are a little bit in the gray area. For example, let's think about a CI/CD build. Typically with the CI/CD build, you're triggered by some action. Someone checked in a bit of code, and then that kicks over or sends a notification to run the build. And if that build fails, then you have a decision tree. Do you retry the build, or do you just alert the user? Now let's take that and try to make it a declarative model. If you try to make that a declarative statement, you may define the trigger. If this source repository sees the change on master, then run the build. And then that could be a declarative object that sits there. And the system will then try to behave and represent that. But here's the thing. How do you represent a build failure? That's a very imperative thing. So what Kubernetes has, and it's a very important part of the Kubernetes API, there's a status field at the bottom. So this allows us to capture the imperative side effects from the declarative statements we make. So when that build fails, if you look at your status field, it will say, hey, this build failed for these reasons, but you're never touching the declarative state that you want, the trigger. You just have the results of the trigger. And people tend to mix the two. some people will put the status as part of the API. And now it's no longer declarative because I'm not declaring that I want a failed build. So why is it part of the API? It's just an output of the API. So that's nuance is really key to getting that right. So when I see people trying to roll a bunch of imperative things into Kubernetes, it gets really tricky on how to build that API without munging the two worlds.
That's really interesting. So in the event of a failure then, what happens? How do you say, what I'm going to do in this case?
So I love this part of Kubernetes. It is on the implementation to eventually get to the state. So this is the whole promise theory, right? So the whole promise theory is that I want a load balancer to exist in region A. That's my declarative statement. Here's the thing. It may never happen, but the control loop may have a policy that it's going to try every 3 minutes until it does. That's the only thing that you can get from Kubernetes. So when people say it's taking long or it's too slow, or let's say there is a failure, well, the promise is I'm going to tell you about the failure and I'm going to try again with no further input from you because the declarative statement is already in place.
Mm. And that declarative statement is valid, it's validated. So it's not like you're going to get a runtime error or anything back, right?
Exactly. So yeah, with these set of inputs, I promise you that I can go and configure a load balancer because I created that contract.
That's how some managers work with developers as well. They just say, this is the thing. Just go and do it.
Keep trying.
I'll try every 3 minutes. I'm going to check to see if you've done it.
But you know what? So here's the problem, and you all probably can chime in. I've never seen a set of product requirements so clear that if I did exactly that, everyone's happy. It's like, hey, I gave you a vague idea of what I want. You did what I asked, but that's not what I wanted. Could you change it?
Yes. And of course, of course, it's hard to do because when we design things, we're doing it at the beginning often. And I don't think we pay enough attention to the learning we get from doing it. I still think that's a big issue that we have just on that point.
I'm going to pull on that thread because it's very important. Kubernetes has an alpha, beta, stable progression, and it's for what you just said. We start with these alpha objects so we can actually learn. Is the API good enough? Is the status field good enough? And what we often learn is that we get it wrong and we start adding annotations to be this kind of side channel for the official API. And then we studied those annotations, and typically the right annotations that are applicable to a wide range of problems become part of the official API, and then you have less. So to me in Kubernetes, the if statement are the annotations. If this is for Nginx and not HA proxy, then these annotations apply.
Yes, that's a good lesson for anyone, I think, writing tech, is that thing that getting things wrong is okay. It's part of the process. I once had a manager who pulled me into his office because he'd look over my screen, and I was doing like TDD red-green testing. He'd look over my shoulder and kept seeing failing tests. So he thought I was struggling. And so, getting things wrong is what we do, isn't it, really? I mean, if you write code and it runs the first time, do you really trust it? I go and break it to make sure it's real. Or, yeah.
Is there anything like being right? To be honest, like we had this discussion at the API design show. You are always wrong, right? Like as you go through, as you gain more experience, you always like have more insights. So it's just almost like impossible to get to the point that you are very confident about the end result.
I think that's why it's really critical to expose as little of the API surface as possible in the beginning, because you can always usually add something, but it's really hard to take away.
Yes.
Yeah.
Yeah, and there is an art too, especially and it's useful in Go. You can do little tricks like putting your tests in the test package. So it's an external package and you import the main package. That's quite a nice way to see the footprint of the API as you're writing it. And keeps that in mind. And literally in the autocomplete in the editors, you'll get, if the list's kind of too long, it gets a bit annoying. Well, that's what it's going to be like for your users as well. So yeah, keeping everything small and don't commit to anything too much. And it's about kind of future-proofing things. But you do have to be honest. The whole team has to be really honest about the reality of writing code. And If you do have influences in the team that perhaps aren't technical or don't think about things in this way, that's when you get a lot of tension between kind of product and tech and these things. So yeah, a part of our mission as developers probably is to communicate and educate on that point. But it can be very difficult to do in practice, but it's really valuable. And so it's great to hear that Kubernetes, this massive successful project, has this approach. It's sometimes it's wrong about things. I think that's a great lesson for people, actually.
Kelsey, you mentioned that you learned a lot from Kubernetes as a developer. I think the Kubernetes has been playing a role as a teaching tool. Developers know more about the load balancers, networking, some of the auto scaling, implementation details, deployment. Some people think that this is an overhead, but I do think that it generally had a better impact to the overall community and making people more aware of some of the critical design primitives. Do you agree with that?
Yeah, so if you think about if you're going to go build a 30-foot skyscraper, usually all of the elements, the bathroom, the siding, the cooling, the heating, is on one blueprint. Maybe there's layers to the blueprint, but if you open up the set of blueprints for the building, everything's there. It all has to be connected. You need so much power to power the building, but you can't figure out how much power you need unless you know how many rooms and requirements. Before Kubernetes, people were really thinking about software at different APIs. Go to the network switch, you program it there. You go to your load balancer, you program it there. There's no single place where you see everything. And the Kubernetes experiment was, what if you took everything that it meant to deploy an app, the secrets, the volumes, the load balancer, even the RBAC permissions to even deploy it, and you give it one common set of languages? We're starting to add security to this, network security policy, Istio policies. And now for the first time as a developer, you're right. We now are putting that front and center. So you can say, here's my application. It listens on this port. It needs these secrets. Oh, and I would like it exposed to the outside world with this DNS name. Oh, and if it fails, roll over to this other region. I can articulate all of that now using a very clean API and submit it to the system and have it converge to the proper state.
Yeah, in a sense that we've been always living in the skyscraper and we were, avoiding the what's going on there. But as the architect, you have to realize the truth. And Kubernetes is providing this really accessible API. And it's just as you said, it's the common language. Once you know it, you can also extend it. And it's a really good foundation.
I'm looking at getting a new house built from the ground up. I've always bought maybe a house brand new, right? And I was like, how long will it take to build a house? And they were very optimistic. They were happy and smiling. And they said, we can get it done in a year. I said, a year? What the hell are you doing? And they were like, well, here's the thing. We have to make sure that the land is prepped. We have to go get permits every step of the way. We need a permit for this piece. We need a permit for that piece. Someone needs to go and check, did we do exactly the work that the permit said we were going to do? And we have to make sure that we have all of that. And then building the house, that's roughly the easy part. Mm-hmm. It's all the other stuff that we have to do because you can't mess up the house and be like, all right, yeah, the roof is off slightly. Don't worry. we'll ship a patch for the roof. No, I don't want a patch for the roof.
I have a question about this. Does this mean that you need a cloud provider to run Kubernetes?
I love that question. So here's the thing. I meet a lot of people that say, hey, I have very little experience. I don't know how to manage a Linux server. Hell, I don't even know how to patch a Linux server. But what I want to do now is I want to leapfrog all of that and just start running a massive distributed system, right? I can do it in probably 10 minutes, right? 15 tops. And I'm sitting there wow, man, that's a bit disrespectful to the industry because this stuff is not this is not a point and shoot camera. There's a lot going on to this, right? We're talking about the difference between making a movie and filming your child's birthday party. These aren't the same things. So I think a cloud provider just brings to you a promise and a knowledge base that says, look, we're managing this stuff for thousands of customers. We've learned all of this stuff. We're obligated to make it work as a full-time job versus finding 10% of my downtime to play administrator. So I don't think you need it. You don't need a cloud provider, but unless you're being honest with yourself, I go back to some of these teams and they got like 20 people on their Kubernetes team because that team is responsible for networking, load balancing, security, metrics, and the application, but they try to put it into the Kubernetes box when the problem is much bigger than that.
Yeah, Kelsey, I was thinking a little bit when you were using the 30-story high-rise analogy and Kubernetes and having this one API fits all approach. And I think the counterpoint to be made is that because it's one API to do all of the things, if you can't encapsulate it into small pieces the way you would for the plumber or the way that you would for the HVAC operator, it can feel overwhelming, right? And it presents a mountain of complexity. So when you said, well, a managed service provider can take away that complexity and do this for you, that was really, I think, a good analogy to extend for companies who think that they want to roll their own and saying, well, if you do, then everyone has to be the Jack or Jane of all the trades. And so that's always the counterpart that I hear when I hear, well, Kubernetes is like, using a 20-wheeler to carry one package. We've seen that meme on Twitter a lot. So yeah, this managed service provider seems to be the way to go. How do you feel like once somebody uses a managed service provider, what is the work to do after that? Where should the focus be? And I know this is going to be not one size fits all.
You know what's interesting? We are a collection of communities of people who can probably do it ourselves. It's one of the very hardest industries to service because we are selling solutions to people who can actually visualize or even have the skill set to just do it themselves. So it's very tempting and enticing to go do it yourself. But think about power. Most people are getting power from a power grid, the equivalent of a managed service. There's some grid by a provider who knows what the hell they're doing. And most people could consider that overkill, that we have these massive grids and we run a line into your home so you can just flip on the light switch. And that works at scale because imagine if everyone tried to build their own grid. Like this would be a straight up disaster. People would be getting electrocuted all over the place. They'll come up with some group therapy like DevOps to talk about what happens when the grid doesn't, like, hey, I've been burned. Everyone's walking around with half an arm because they don't know how to run power grids. And there'll be a bunch of conferences about how to run power grids. And there'll be 20, 30,000 people talking about how to best manage power grids. This is what we're seeing in tech right now. Lots of people are trying to be cloud providers part-time and without the same level of budget. So as the technology advances, you're looking at this from a thing is like eventually it starts to make sense. And maybe there's a trust thing that's missing. Like with power, we assume that it's always going to flow. And when it stops flowing, it becomes like a national emergency if we have a blackout or something like that.
Yeah, it's like the purge.
Wow. Just
That's a bit extreme.
I'm surprised how quickly it becomes the purge once we have a power cut.
Wow. Okay. That's an extreme thing. You're right, though, because people do feel like there's chaos, right? Like if a region goes down, the number of people who go to Twitter and just start going crazy.
Yeah.
Like you're right.
Yeah. So along the lines of sort of building our own power grids, is it fair to say that there's a bit of FOMO, right, with the people who could do it themselves, right? Is it FOMO that's driving them to say, well, I should try this because, heck, I mean, if I'm being selfish, this is a career thing, right? I want to know how to run Kubernetes clusters and do this and that. So now you have this sort of a resume-driven development, as we tend to call it. Sort of a little bit of that, right? That's kind of even in the back of your mind, even that little voice in the back of your mind saying, oh, you maybe, yeah, why don't you push for it? You can do that, right? Is there a bit of that?
I'm going to admit I'm the world's biggest hypocrite right now. I'm starting this podcast, right? And I got some recordings, I got the dope mic, I'm ready to go. And I was like, I need to host this podcast somewhere. And I found all of these services. They're like $10. Some of them were even free. They're like, you just come and fill out this form. They'll host your RSS feed. You can even upload your MP3 and you're done. I was like, nah, man, we ain't going out like that. What I'm going to do is write XML by hand, read about all the tags. I got my RSS XML. I put it on Google Cloud Storage. I got my MP3. I did the ID3 tags for the MP3. I put a CDN in front just so I didn't have to use a managed service. Because you're right. I had this appetite for, I want to know exactly how podcasts work. I want to know, I want to have full control. I want to back up my data. I don't want some limit telling me I can only stream 50 concurrent streams at a time. I was like, you know what? I know what to do here. I got this. So I spent 2 days to save $12.
Oh my God. I think you just explained our collective zeitgeist or pathos as an industry. Like why our ecosystem is an embarrassment of low-level riches, right? Like we need to, in this new decade, we need to innovate. We need to make Kubernetes boring. We need to experiment. We need to move up in the abstraction chain, but yet we also need to fundamentally know how things work. And that's the paradox we're in.
Yeah, and I think, honestly, if I were to recommend this to someone else, I value the knowledge of how podcasting works than the service. And I think, yeah, you're right. Our industry really appreciates the knowledge and the power that comes from the knowledge versus what the business actually needs. And I think that's the question 22. Like your business needs to survive, it needs to grow, it needs to be efficient. And sometimes you can leverage a cloud provider and make margins on top. That's just good business. But when we're at the helm making the decision, we're like, yo, forget good business. I'm about to deploy Kafka to process 25 messages a year.
It's nerd pride, right?
Seriously.
Yeah.
Hi there, this is John Calhoun, one of your GoTime panelists. When I'm not working on GoTime, I create programming courses that help developers level up their Go skills. And one of my more recent courses, Algorithms with Go, is live, and I wanted to invite you to check it out. So it's completely free, and in it we explore how algorithms and data structures work, as well as how to actually implement them in Go code. So if you've ever had an interest in learning about algorithms or data structures, or if you felt like you understand them conceptually but just couldn't nail down that coding part, this course is going to be great for you. We actually dive into coding everything, we work on practice problems, and it's a lot of fun. You can sign up completely free at algorithmswithgo.com/GoTime. Again, that's algorithmswithgo.com/GoTime. And don't forget that last /GoTime bit. It helps me keep track of how you found out about the course so that GoTime gets credit for referring you. Thanks for listening.
So we've been talking about the API for some time, and I think there's a reason for that. Is it fair to say that the learnings, right, the journey that we've gone through to have the Kubernetes API as it is today, is that really the crown jewel, right? And this is why I'm asking that. We have projects that are looking to make sort of Kubernetes simpler, right? One of the things you're going to hear over and over is that, well, Kubernetes is a complex system. There's a lot of moving parts, right? You just got to know what you're doing, kind of thing. And yeah, we're going to have the people who are going to geek out, and they're going to go through the manual. They're going to figure out, okay, this knob goes here and this one attaches here. I mean, they're going to figure it out. Great. But you have projects that are trying to simplify that, right? Using the same API, the same abstraction, right? I can think of things like K3S, right, versus K8S, right? There's that common ground, right? That is the API. Is it fair to say that the Kubernetes API itself, as we know it today, is really the crown jewel of this project?
Yes. And the reason why it's important is that Kubernetes makes it easy to have hyper specialization. Like the internet is one of the best examples of hyper specialization. Some companies just make web browsers because you can rely on the specific protocols to show and display web pages. Some people go to Best Buy and you buy a modem and you screw it into the wall, and now you're online, right? Because now everyone can just hyper specialize because the connectors, their protocols are so standard. But remember, the internet is just massively complex. But the things that exposes means we can specialize. So if you are an ISP, you view the internet differently than someone watching Netflix, right? It's just totally different ballgame. Kubernetes is meant to be the same thing. If you need to run at a global scale, meaning I just need to be available everywhere, I need to be able to pick and choose my provider of choice, then that's going to require a much more complex system to lay on top of that. It's infrastructure. Now, that's for people implementing that kind of capability. You can either buy it or you can build it, but you don't have to start from scratch. You download Kubernetes and you start from there. And then there becomes implementation details. So when I lay it on top of my infrastructure, if I got to lay it on top of GCP, you're probably better off starting with GKE. If I have to layer it on top of Amazon, you're probably better off starting with EKS, because all of the integration work to make it all really run underneath, that's the hard part. It's like what Linux and distros do, right? The drivers, the default package manager, etc. Linux is also complex. On the other side, as a developer, let's assume that either your team or whoever you bought Kubernetes from is doing a good job in terms of keeping that thing available. You get to then deal with a different API. You get to say, Kubernetes, run this. Kubernetes, run that. Kubernetes, tell me when that is no longer true. And for some people, that's all they know about Kubernetes. They've never installed it before. All they know is that if you give it things, it runs them. And when things aren't working, here's how you leverage the API to troubleshoot them. We have to do a better job as an industry of separating the two.
Well, what about the future? I mean, we're getting better and better and better at having managed service providers to be able to help you get jump started and provide value to the business. But I know you've also talked a lot about serverless and maybe that kind of form of compute. Can you talk about maybe what this decade should bring and where maybe operators and why they would choose that instead?
Yeah, so the thing about serverless, I think that hype cycle will be very short by design, because they have the right focus. Their focus is to make something useful without managing the server or infrastructure underneath it. That means that there's no reason to have long hype cycles. Think about it, storage. I just upload some files. There's no need to have storage con. Upload the files. I don't really care how you're storing my files. I just want to make sure that they're there when I need them. And when you look at the service philosophy, it's more about the APIs and getting things done than implementing the system underneath. So now we're asking ourselves, in the future, what else is going to get the serverless treatment? We've seen it done for email. We've seen it done for storage. We've seen it done for the internet. Most people use the internet in more of a serverless model. Mm-hmm. So right now, the last thing that's really standing are databases and compute. These are like the two things that just won't die for the things we talked about earlier. People believe that they can do it themselves. One day, I believe that there will be a CDN-like database. CockroachDB hints at this. The Spanner team also tries to provide this for customers. But imagine a world where you go and you just put your data in a thing and it's just available everywhere. That's going to be a game changer, and maybe people may not want to deal with database servers individually anymore because it just don't make sense.
Yeah, it feels like this, sooner or later, the core competency of companies is not to run Kubernetes clusters in the same way that we're not running our own data centers anymore. And that core competency is going to shift elsewhere.
Or just make sure you get a lot of value for doing that yourselves, right? There's lots of companies where running a data center does make sense. If you think about what I think may happen, someone's going to collapse some of the layers. I remember when Oracle, I worked at enterprise a lot of my life before going to the startup world. And I actually, so you know what? What makes me the most valuable now is I had that context of reality. And having these AIX boxes or Solaris boxes running Oracle and everyone just praying at the server not to go down. And when that happens it becomes a very complex thing where you start to have 50 Oracle DBAs to manage 2 database servers, tweak and tune indexes, deal with the file systems and upgrades. And then Oracle did something amazing. Like 10 years later from my initial exposure to Oracle, they came out with the Exadata. They were like, all right, that's enough. We're going to wheel in this refrigerator-sized thing. And it has the storage, the SSDs, all the RAM, and you're going to close the door. Now, here's the thing. If you open the door, don't call us. Leave the door closed. Don't mess with it. Don't DevOps it. Don't rub Kubernetes on it. Nothing.
Don't even look at it.
Yeah, if you look at it, it costs extra. Right? They send you photos of it. And you pay the invoice so you know it's there. But the key there, though, is that now people just start to focus on using the database and not managing the database.
Yeah, I mean, that's me. That's my whole approach. It resonates a lot because I think when I'm building things, I want to just focus on the bits that are important or that are unique that I'm doing. I really don't want... I mean, if I could just get away with just stitching some things together to build a product, then I'm very happy doing that. I use Firebase quite a lot. I'm working on a new project, and we've chosen Firebase, or we're doing experiments with it. And technologies like that, alongside other things like App Engine and things, it takes away a lot of the things I have to worry about. And it is slightly abstracted, and there are times when it doesn't quite fit perfectly, of course. But yeah, I do think that's the right approach, really. I'm not going to add much value by kind of doing these things myself. I don't even get that nerd pride thing where I think, oh, I'm really smart because I made this thing. So I'm definitely not going to be doing that.
If you're listening to this and struggling with this concept, imagine you work in the IT department and you hire 10 new people a week, and you give them their laptop and you give them the desk assignment, and they go sit down at the desk and you say, hey, before you can get online, we practice DevOps around here. Here's a crimper cable, and here's some raw Ethernet. And here's 2 end clips. You only get 2. So if you crimp this thing wrong, you don't get online. And you lay the kit at their desk and say, hey, make a Cat5 cable. Remember the crossover in the middle. And then you can get online. And people will be sitting there like, what the hell are you doing? I have work to do. It's like, you need to make a patch cable first so you can get online. That is what we're asking developers to do every time we expose infrastructure to them at that level.
Yeah. They need to work at that highest level of abstraction, as Matt was talking about. For him, Firebase does that for him.
Yeah, it's really about the important bits. What's important for what I'm doing? Where's the value that I'm bringing? I think also we do a thing which I think might be necessary, which is kind of like ignorance-driven development as well. So when people see the finished, or finished in quotes, product, or whether it's a good user experience design or something, when they look at that, it just seems obvious, because it's matured. So it's been through the pain, the process of figuring out the right thing. And so it looks easy. That's the thing. So when, we're kind of ignorant about things, I think if we knew everything that was involved in a product before we started it, we'd never start anything, because it always ends up being really hard and really complicated, always, even very simple projects. So we kind of need that, don't we, naivety at the beginning and that ignorance.
Well, so I think it's hard because so far in the industry, we've attached negative terms with specialization. Silos are bad. Not being a wider range of skills are bad. See, I don't think that's necessarily true. If I hired someone to do development, I want to get them to focus a lot on development. If I'm in ops, I'm hoping part of my job is so they can focus. There's nothing wrong with focus. Maybe there's something wrong where I'm not able to help you focus because we need to collaborate to get there. But once the collaboration is done, can we not serialize the results so that tomorrow we don't have to go through this again? Right? So I think the goal is I want people to be able to hyper-focus and be the best person they can be while not preventing them from learning other things if that's what they choose.
Well, you said in your Oracle experience, they collapsed layers so that people could focus on a specialty rather than all the other layers. And that still made that particular specialty was still very, very productive and fruitful, and had lots of developers still working on it. So even if we were to collapse layers, we're still going to find more work to do.
I feel like maybe specialization is, there's some stigma, or people doesn't necessarily want to specialize because tech is changing so fast. If you just know how to wire the cable, it means that there's no guarantee that you will be able to, take it to the next level. And in tech, we change the way we work in every 2-3 years. So I think that's one of the main reasons people try to avoid to specialize. Yeah.
You're right. Specialization is a risk. Right? If you over-specialize, you may find nothing to do. So I think a lot of times we take turns being specialists, even at the same job, right? You may specialize in QA for 3 months, and then you may specialize in development for another 3 months. And then when you step back, you say, hey, the last year, I've grown in 3 areas. But I typically like to focus when I'm working on one thing, right? Like, hey, I don't want to play infrastructure person while I'm trying to figure out how to do my podcast, right?
Yeah, the same applies for limiting scope as well. If you try and do too much in a product, you kind of can only touch the surface on everything. Versus if you strip it way back and limit the scope as much as possible, you can really do a great job on those things. It's kind of a way to be a 10x developer might be to divide the workload by 10. I'm not a mathematician. I assume that works. We'll edit it out if it doesn't.
Good luck.
I think that is the premise of the book Essentialism, Matt. if you've read it, by George McEwen. Yeah. No, but it's true. But I think that's kind of where I want infrastructure to go. I mean, I like that we've been so low level, but when Kelsey, you started off the podcast saying that it's finally kind of getting boring, I think that means that we've collapsed some layers and we're finally letting people get on with solving real problems for their business.
And we see this in the runtime space quite a bit. So when I look at like the Go project in general, we have a very massive standard library that most people don't really think about implementing the HTTP protocol from scratch. You import net HTTP, and there's still room for improvement for higher level things. But I think the programming world has really come to the conclusion that you need good standard libraries, and then you kind of need a second layer of good standard common libraries that everyone just uses before people start writing their own libraries for very common things.
Yeah, I do think it applies all the way up as well. Like there's Hugo, that static site generator that was started by Steve Francia, and the Buffalo project, which is a kind of hyper example of that, where that is extremely high level and abstracted away from a lot of the other things that are really going on in that application. And the evolution of that, I know that they are working towards a V1 release. And, it's that same kind of principle, really, that, you don't necessarily have to build all the things. The point is to get something good done and then get some value from it, get people using it. You learn so much by doing that. I never can stress it enough.
If Practical AI isn't in your regular podcast rotation, it's time to fix that. Daniel Whiteneck and Chris Benson are on a mission to help you put AI tools and techniques in practice. Here's a sample of what to expect. It's from episode 64, and the guys are discussing how OpenAI trained a pair of neural nets to enable a robot hand to solve a Rubik's Cube. Take a listen.
But here they're talking about emergent meta learning, which sounds like this really weird term to me. And it's almost like a term that doesn't mean anything. It's like emergent and it's meta.
Very new age sounding there.
Yeah, what does that even mean? I'm not sure. So what did you get, if anything, from that?
Well, I actually drew an analogy between what they were doing with that and kind of what we as humans do, in the sense of, as they kept cranking up the difficulty by changing the parameters into something more difficult, it reminded me as I read that about, for instance, teaching my daughter to ride a bike, and first just learning how to sit on it and pedal with training wheels on and start steering it, and then as she got comfortable with that and going over curbs and then taking the training wheels off and having to learn how to do balance and all that.
Practical AI is filled with goodness. Check it out at changelog.com/practicalai, or just search for Practical AI in Apple Podcasts, Spotify, or your favorite podcast directory. You'll find it. While you're at it, upgrade to our master feed at changelog.com/master and let your podcast app download all of our shows. Then you can pick and choose the ones you're interested in and skip the rest. What have you got to lose? All right, back to the show.
So we're coming up on our time with Kelsey, and it's been awesome having him. But I'm also interested in perhaps maybe something controversial from Kelsey.
Let's do it.
We're trying to introduce a new segment to the show that focuses on unpopular opinions.
Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion.
Now, I know a lot of people like most, if not all, of the things Kelsey says, but I'm interested in hearing something that perhaps folks may not like from Kelsey?
So this is where you have to bring in the unpopular opinion and let people comment on it. I think like one unpopular opinion people have that people disagree with me a bit is there's two. Don't run stateful things on Kubernetes. That's a very unpopular thing because people want to Kubernetes all the things. And I'm just saying, but why? Okay. And then the second one is monoliths are the future.
Ooh.
Because the problem people are trying to solve with microservices doesn't really line up with reality, right? So just to be honest, like and I've done this before, gone from microservices to monoliths and back again in both directions. And most people say, look, we lost all of our discipline in the monolith. We just started creating classes. This person went and bought the Django 4 book, came back and started doing design patterns and then quit. So half our code base is doing this thing over here. So now it's a nightmare. So now the code base is so bad. You say, you know what we should do? We should just break it up. And we're going to break it up and somehow find the engineering discipline we never had in the first place. And then what they end up doing is creating 50 deployables, but it's really a distributed monolith, right? So it's actually the same thing, but instead of function calls and class instantiation, they're initiating things and throwing it over a network and hoping that it comes back. And since they can't reliably make it come back, they introduce things like Prometheus, open tracing, all of this crap. I'm like, what are you doing? Now you went from writing bad code to building bad infrastructure and what you deploy the bad code on top of. There are reasons that you do a microservice. So to me, like a microservice makes sense in the context of you're a bank and you have this big monolith that does everything. Then mobile comes out. You want to do mobile banking, but it requires a different set of APIs. You don't have to add that to the monolith. You can go create a new application that handles most of the mobile concerns and then connect back to the existing infrastructure to do its work. That makes sense to me. But this idea of microservices are a best practice, it tends to be unpopular with most people's initiatives, right? They're like, oh, we were bringing in Kubernetes so we can do microservices. We are going to re-architect everything because it drives a lot of new spend. It drives a lot of new hiring. So a lot of people get addicted to all the flourishment of money and marketing, and it's just a lot of buzz that people are attaching their excitement to, when honestly, it's not going to necessarily solve their problem.
It's so true that microservice architectures that I've used, you end up, the components are coupled anyway. One message from one thing, if it doesn't go into the other component or the other service, then your thing doesn't work. So it's coupled, they are. It really does make sense. But what about the practical, like, team working aspect? Because one of the benefits of having microservices is you can kind of break your teams up in that way and have the teams working somewhat independently.
So now we're talking about the problem with merge conflicts. At least my experience has been, how do we avoid merge conflicts? I know, let's start another repository, right? And let's have a better API contract. We've been so bad at language level API contracts, we decided to leverage things like JSON and RESTful interfaces to give us a much harder contract. They're very hard to violate because they're so rigid. You can't reach behind the class and call a method because you can't do that with REST. It's not easy. So I think what happens in the team aspect is, I like the idea of modules, right? So like when I saw the way Go did modules, you can actually have separate teams building modules, but that's independent of how you compile the modules into the final deployable. So at CoreOS, I remember we used to do this a lot. We used to have a lot of individual modules, and then package main is where the collaboration happened, right? I would bring in my module and maybe add a route to it or something. But once you touch that file, it's only because you're saying, hey, I'm now part of the contract. Here's my route. But then I would just go do the rest of my work in the module and allow the build system to take all of our work and combine it together. And if you're using tools like Bazel, it could be build one big binary, build 3 little binaries with flags. But either way, that's a separate concern. I think the way you lay out your source trees and how you develop code collaboratively versus how you deploy the results of that effort.
I mean, it's funny because we are just starting a new project now. So I get to use all of my kind of past experience on a greenfield project, which is tends to be quite a unique thing to do. It's rare.
Your resume is about to get amazing.
Yeah. Yeah, our approach is always to just kind of, we'll start simple, whatever's the simplest thing, so that we can get it working, and then let patterns evolve or emerge, and let different problems kind of present themselves, and then you can solve them along the way. And it turns out, in the beginning at least, it is going to be a kind of a monolith. And there's so far no problem with that. Another way to kind of solve some of the other problems we talked about is just not to have loads of people working on a project. It's not always possible, of course, but when it is, that's a great way to cut out a lot of problems. If there's just 2 or 3 of you building something, it's so much easier. Yeah.
The communication overheads to me in any distributed project are always the biggest ones, the biggest things that you need to solve for.
Indeed.
Yeah, I actually pair program exclusively with my business partner, David Hernandez. We only pair program, so we immediately both know everything about the whole thing. And we're basically doing the whole stack, but it's small enough, at least at the moment, that's okay. And if you can keep it small, I think you should. It's a goal that you should have. It pays dividends immediately. I can't advocate for it enough. It's not always possible, of course, but it fights a little bit this instinct, particularly if you do raise money and you're VC backed or something like this. You want to hire and you want to build the team because that's what you do. But I think it's worth just taking a step back from that, and maybe you don't need to do that way.
To be fair, I worked for a company. I was the only developer, and we were developing 10 microservices.
You were developing 10 microservices.
Exactly, yeah. So just for the sake of, following the microservices pattern, we were doing it. And I think that this is a very common pattern in the industry.
Well, we look left and we look right and we say who's doing what. I mean, no, really. That's also why we use common libraries, or why we would use, I remember working at a company saying, why are we doing testing this way? And it's because, another company did it, or we just, and it's kind of, the real unspoken truth about our industry is we sometimes look left and right without any real sitting down and reckoning with what works for us.
Yeah. Everything we build, if you spend long enough on a project, you end up hating it. So whatever you've done, you've got something you hate. And we had a monolith, we hated it. We did microservices, we hated it. If you spend long enough on a project, you're going to hate it. And I think that drives a lot of decisions. You just want something different. You just want something fresh sometimes.
Novelty.
Humans crave novelty. Humans absolutely crave novelty.
Yeah.
Indeed.
That's why I'm wearing these glasses. They're not even real.
Well, I took a screenshot. I'll share on the Twitters.
Wow. All right. Wow. So this has been like an awesome episode. Thank you again, Kelsey, for coming on and for regaling us your tales of putting together an entire infrastructure for your podcast to save $12.
You're going to open source that, by the way?
I am. I actually have a set of command line tools that I will be publishing, because I also do some things like translate the audio using some of the cloud APIs. So, you gotta move it to the next level. So you'll see that coming soon to GitHub.
You're a nerd in the best way, Kelsey.
What did you write it in, Kelsey?
You know what? I just fell back to Java. Go just was. I'm joking. It's written in Golang. Come on. What are you talking about? So it's going to be written in Go. Yes, of course.
Oh, troll of the year right here. Awesome. Well, thank you all for being part of the show. Thank you all for listening, and we'll catch you on the next Go Time.
All right, thank you for tuning into this week's episode of Go Time. If you're not yet, hang with us and go for Slack. We have a channel called Go Time FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.